All right, today we're talking about two more theorems, Rolle's theorem and mean value theorem. Rolle's theorem states that if f is continuous on the interval a to b and differentiable on the interval a to b, if f of a equals f of b, then there's at least one c such that f prime, or one c should be on the interval, let's see, on a to b, such that f prime of c is equal to 0. What this is saying is if you have 2 points on your graph at the same y value, 2 points on the graph at the same y value, and you know the function is continuous between those 2 points and differentiable between those 2 points, so no sharp turns either, then you know somewhere in between those 2 points you have to have a slope of 0. And that should make sense. The only way you can draw a connecting line between those two is either a straight line, which is a slope of 0, or a curve, which eventually turns back the other way. There's no way to keep going this way and keep going and not get back down to there. You're going to have to make that curve, and we have a slope of 0. That's all this one's saying. So let's look at some problems that relate to this. First type is, does Rolle's theorem apply to this interval? So this function between the x-intercepts. First thing is to find the x-intercepts. So f of, honestly, we don't even need the x-intercepts because, well, we do need the x-intercepts. Yeah. Technically, we don't need to find them, but we do need to know the interval that we're on. So we're going to find the x-intercepts. 0 equals x squared minus 3x plus 2. We'll factor it. X minus 2, x minus 1, x equals 2 and 1. So those are our x-intercepts. So our interval is from 1 to 2. There we go. All right. So what we're checking is it continuous and is it differentiable? So this is a polynomial. It means it's going to be continuous. Its derivative is also a polynomial. It's also going to be continuous. And Rolle's theorem says if the y values at those points are equal. Well, the y values at both of these points are 0 because they're x-intercepts. So we have, since f of x is continuous and differentiable, at all points, and since f of 1 equals f of 2, then Rolle's theorem applies. Okay, simple as that. Now, this one's a little bit different. Does Rolle's theorem apply on the interval -1 to 4? So let's start by plugging them in and seeing if they equal. F of -1 is going to be -1 squared minus 1, which is 0 over -1, which would give us 0. F of 4 is going to be 4 squared, which is 16 minus 1 over 4, which is not 0. 15 over 4. So these are not equal, so Rolle's theorem will not apply. Now, there's actually 2 other reasons Rolle's theorem doesn't apply. First, it's not continuous on the interval -1 to 4. 0, if you plug it in there, would make it not continuous. It's also not differentiable, because if it's not continuous, it can't be differentiable either. So no, Rolle's theorem doesn't apply because, and then you can put any one of those reasons or all 3 of those reasons. This should be B/C. There we go. Okay. All right, looking at this one now, checking if Rolle's theorems apply. I'm not going to go through this one with you. You can go through it on your own, but you're just checking, does it apply on the interval? The next one we're looking at is mean value theorem. Now, Rolle's theorem is really kind of tricky, not because it's hard, but because it's actually a mean value theorem problem that has been very specifically narrowed down. Mean value starts out the same way as Rolle's theorem, let f be continuous and differentiable, then there exists at least one c such that this equation. Now let's talk about what this equation means. This is saying the instant rate of change, or the slope at a point, is equal to the average rate of change, or the average slope, or slope between 2 points. Let's put it that way. All right? The slope at a point is equal to the slope between the two endpoints. So this one's a little tougher to visualize. But if you have 2 points on the graph and the function's continuous between them, so some weird line like this, then you know that somewhere on this line, because of the nature of the graph, this slope between these 2 points will be the same as the slope along the curve somewhere. So this slope right here would probably match, or this one right here, or this one right here a little bit. Maybe. It might be a little more off. But it's saying it has at least one point where the average rate of change is equal to the instantaneous rate of change. And we can even see that at the base example as well. You have 2 points, draw a straight line. The average rate of change is the slope of that line, so the average rate of change and instantaneous rate of change would be the same. Now, this doesn't mean the instantaneous rate of change is the same at all points between it. In this case it is, but not in every case. It just means there will exist one point where the instantaneous rate of change is equal to the average rate of change. So let's look at a problem that might ask about this. All right, apply the MVT to f on the indicated interval, find the value of c such that this happens. So this is telling us, hey, use MVT on this interval. It's not asking us to like prove that it exists. It's just saying use MVT. So we're saying, okay, what is the average rate of change? And then where is the derivative going to equal that? So we'll start with the average rate of change. F of 4 minus f of 1 over 4 minus 1. So plug in 4, we get 5 minus 1, which is 4. Minus, plug in 1, we get 5 minus 4, which is 1, over 4 minus 1, which gives us 1. So our average rate of change is 1. So what we're looking for is where is the derivative equal to 1? So let's take our derivative. Well, to take this derivative, we probably want to change this 4 over x to 4x to the negative 1. F prime of x is 4 over x squared. And then we want to find where this is equal to 1. So 1 equals 4 over x squared equals 4, x equals plus or minus 2. Looks like we have 2 answers there. But remember, MVT only applies on the interval. So we're looking for the point that is in between 1 and 4. Well, the only one of those that's in between 1 and 4 is positive 2. And so c is equal to 2. Our x's are 2 and negative 2. Our c is equal to 2. No statement needed for that one. Here's another one you can try on your own. Let me know if you have any questions. Aside from this, you have a worksheet that you can work on. It should be on Canvas. You'll have a great day.